Greetings, welcome back as we find the product moment of inertia. Will be done soon, I know. So Ix, Y is what we are interested in finding for the whole shape, for the entire shape. You still remember the shape? The L shape. Broke it down into two. One was Y, this was X. C1, C2. This was the centroid. Okay. So let's go ahead and find xy. Xy for the whole shape will be equal to Ixy for shape 1 plus Ixy for shape 2. Okay. And the sum of those product moment of inertia will then give us the absolute or resultant moment of inertia. So Ixy 1 is equal to Ixc YC. This we are speaking about the centroid of 1 plus area of 1 multiplied by d1 d2. Okay, so mass moment or product of inertia about the centroid of any object is 0. Reason being the position of the center, for example this center C1 from the center itself is 0. Therefore 0 times 0 will give us 0. So this is always 0. And we are just left with A1, D1, D2, where distance 1 and distance 2 are simply, what is D1? D1 is, okay, I can name D1 as the position of the centroid of shape 1 from the y-axis, so which is x1. So D1 is x1 and D2 is the position of the centroid from the x-axis, so that is y bar 1. Y bar 1. Alright. So what was the area? Area for area 1 was 2250. 2250. 2250 multiplied by x bar 1. X bar 1 7.5. That was 7.5. and 75. Y1 was 150 divided by 2, which is 75. Okay, so this give us 2250 multiplied by 7.5 multiplied by 75. This will give us 1.266 times 10 to the power 6 millimeter to the 4th power. And IXY, it's called product of inertia because, well, as you can see, it's a product of moment of inertia in Y, moment of inertia in X. See, X and Y are multiplying each other. The axes are, we have a product of the axis. So IXC about C 2, this is 2 plus area 2 multiplied by X2 Y2. Know that this is 0 because the product of inertia of a centroidal axis from itself is 0. There's no position. And area 2 was 1275. 1275 multiplied by X2. 57.5. 57.5 multiplied by 7.5. Okay, 1275 times 57.5 times 7.5. That gives me 549.8 times 10 to the power 3 millimeter, the 4th power. Okay, in case you're wondering where the distances were, X where we have X2 and Y bar 2. All right. So now we just add those guys up. IX the summation of IXY is equal to the sum of these guys. So 1.266 times 10 to the power 6 plus 549.8 times 10 to the power 3 plus 1.266. That gives us 1.8. gives us 1.8, 2 times 10 to the power 6 millimeter, the fourth power. Alright, so that's how you get IXY, and from IXY then we can find I1. To get I1, so I1 is equals to IX plus IY divided by 2 plus square root IX minus IY divided by 2 squared plus IXY squared. This is why we needed to find this one and that one, so that we can be able to solve for I1. We know that this is the same thing as I average, and this is the same thing as radius of the Mohr circle. So you can just work these guys out. What was IX? Get I average IX plus IY over 2. $16.97 was IX. 16.97 plus, can drop out the 10 to the power 6, because I know already that they are all 10 to the power 6. I'll add it at the end just to simplify my calculations to make it faster. So this will be 16.97 plus 5.152 divided by 2, 11.06 times 10 to the power 6 millimeters times 10 to the power 6. Okay, and R $16.97 minus 5.152 over 2 squared plus IX. What is IX? $1.82. $1.82 squared $6.183 times 10 to the power 6. Right. Therefore, I1 is equals to I average plus R, which is the same thing as 11.06 plus 6.183 gives us 17.24 times 10 to the power 6 millimeters, the fourth power. And I1 is just the minimum, which is I average minus R, 11.06 minus 6.183. 11.06 minus 6.183. 4.88 times 10 to the power 6 millimeters to the 4th power. So yeah, this is I1, that is I2, and finally we can get the angles from this. Tan 2 theta p is equals to minus 2 IXY all over IX minus IY. Okay, so minus 2, what is IX? It's 1.82. 1.82 divided by 16.97. 16.97 minus 5.152. 5.152. You can see I'm skipping the 10 to the power 6 because it doesn't make a difference here. Just to give the same answer. So minus 2 times 1.82 divided by 16.92 minus 5.152. Minus 0.309. Therefore 2 theta p is equals to tan inverse minus 0.309, which gives us minus 17.188 degrees. Therefore theta p, 1, divide that by 2 to have theta alone, minus 17.19 divided by 2 gives you minus 8.59 degrees. Then theta p2 minus 8.59 plus 90 that gives us at 1.41 degrees, and we are done.